Hello and welcome to the code screencast of my project Hobby Kitchen for the course TDDD27 Advanced Web Programming. So before jumping into the code, I will first talk about the architecture and the technical aspects of my project. So on the client side, I am using React, and on the server side, I am using Spring Boot with JPA Hibernate implementation and a MySQL database. And the client side and the server side are communicating through Axios library. Also, on the client side, I'm using Docker to create an image of my Spring Boot application, which I run inside a Docker container. And I pull an image of a MySQL database from the Docker Hub, which I run inside another container. And these two containers communicate through a link and expose a port 8086, which is then consumed by my client side. Alright, a few technical aspects about my project. So I'm using Spring version 2.7, MySQL version 5.6, build tool as Maven, and Hibernate with JP implementation. Also Docker on the back end, and on the front end I'm using React version 5 and Bootstrap CSS, Material UI, and few of some other libraries, which will be much clearer when I explain the code. Alright, so let's look at the code. So first let me show you the structure of my project. So I have this assets folder where it's just a CSS file. Then I have around 20 components which are used in this project. But, and since there are three use cases, one when the user is not logged in, one when the user is logged in with the user role, and the third one is when the user is logged in with the admin role. So all of these components are bifurcated on the basis of that. Alright, and inside images I have all the images and the video that I'm using, and inside services I have the actions and all the reducers that I created for every component. And inside utils I have this authToken.js, which is required for session validation and invalidation. I will talk more about this towards the end of this part. Alright, so let's go in order and start from app.js. Okay, so this app.js is a functional component, and it basically has all the route paths for all the components, and I also have three functions. This function is just to ask the user permission when he or she is about to refresh the page, because whenever the browser is refreshed, the session is invalidated and the user is logged out. So to prevent that, every time the refresh button is pressed, then the user will get a prompt asking that whether he or she wants to leave the page or not. And then I also manage the state of my cart items from app.js, and I pass this on add, on, and on remove functions to the respective child components, which are then further used in them. Alright, so let's move on to the login page maybe. Yeah. So login page is also a functional component where I'm using hooks such as use state and use dispatch, and the input from the user, the email and the password, and then I'm setting that in the state. And this credential change function is called from an onChange property of the text box below. And then when we enter the email and the password, then this validate user function is called. And inside this I dispatch this authenticate user function, which is implemented inside my services. So what happens here is we do an Axios post call, and then we receive the username, the user role, and a JWT token, which is uh, valid for about 10 minutes if the user does not do any other request in the meantime. And we set that JWT token inside our local storage so that we can use it to validate the URLs or the calls that we are doing to the backend, right? And we do that using this auth token.js. So whenever the user is authenticated and uh, the token is set in the local storage, and we are logged in, then every call that we do, every request that we make to the backend has this authorization in the header and this token as a value. And without these token, we won't be able to communicate to the backend, and the session will be invalidated. And also, if there's no activity on the user sides for more from somewhere in between 5 to 10 minutes, then this token will automatically expire, and the session will be invalidated again. So coming back to uh, login, so we authenticate the user, we set the user details in the state, and we set the JWT token in the state, and then if everything is successful, then we just redirect it to the home page. And I think the next important component and a bit tricky component to implement was the navbar. So when we log in, this navbar is re-rendered again. And here I am also using a few hooks like use state, use selector, use dispatch, and what I'm doing is that I'm getting the value of auth from the state, and this auth is nothing but the values which we set before, which I showed, the username, the user role, and the JWT token, and is logged in or not. So if we scroll down, sorry, then this is the link to the home page, which has an image or the logo, and on the basis of if user is logged in or not, we are showing the user links or the guest links. And inside user links, we have further bifurcated on the basis if the user is admin or not. So for every use case, we are showing different components, and we are doing this by whenever a user is logged in after that. I think the next pretty good component that I implemented is the menu. So let me open menu.js. Yeah, so this is also a functional component, and I'm using use state here, and I'm also using the props. So this on add function is passed on from app.js to here, and it is further passed on to a child component called single dish. So the single dish component is basically a card uh, component which shows all the card, and it is reused in the code whenever I want to show a dish. You know? And so I just use this use effect, which is called every time the component is re-rendered. So we fetch all the dishes, we set them in the state, and then when we render them in the card body or in the table format. And these were the functional components that I implemented, but almost 60% of these components are class-based components. For example, one of the difficult one was the users.js. Let me open it quickly. Yeah. So this is a class-based component, and this is basically doing the same thing as a functional component, but I was pretty familiar with classes and how this works, so I created most of the components as class components. But after completing like 50% of the project, I realized that hooks and functional components are just as important in React. So almost 40% of these components are functional components, but they are basically doing the same things, but class components takes a bit more line of code and is a bit more complicated as compared to the hooks. But once you get used to it, then it's pretty easy. So this component inbound method is the same as use effect, and this dot state and setting the variables is basically setting uh, like doing use state. And to use props, I have to use connect from React Redux, uh, like this. Maybe I can show you that first. So whenever we want to call a function, we define it in map dispatch to props, and whenever we want to get something from the state, we use map state to props, and we use this connect from React Redux, and then we pass both of these to the connect, and then we export the users. So we can use this data in this components from the state also. All right, and so this is basically the same code. Like we have a bunch of functions like change role and change page and first page, which are being called from their respective uh, text fields or buttons, and I think are being used properly. Yeah, but I think that was all about the front end. Then uh, there are a bunch of things that I did. The most difficult part, I think, was the handling the authentication part and validating and invalidating the session, and also using the use dispatch functions. And one of the good things that I did here was to implement these services. So for each type of action, I implemented this actions, which contains all the functions which have access calls in them. And I have implemented reducers, which uses that, uh, and I have also like kept the variables of each types in a different file. But when I was using these actions and this reducer in my component, then the number of imports just grew very much. So what I did is that I created a common file like a root reducer, and then I imported all the reducers, and whenever I wanted to use a reducer, then I just call this root reducer. And I did the same thing with actions, and I exported all the actions. So if now when I want to use an action, I just import this index, and that pretty much worked. Yeah. But and also the CSS implementation for this project was also a bit difficult. As you can see, that almost like every component has its own CSS file, and has a different CSS implementation. But most of the common CSS implementation is inside app.css, which you can see is like pretty long. and almost all of these components have these @media screen files, which makes it a small screen or mobile device compatible. So that was, I think, a lot about the front end. Now let's move towards the back end a little bit. Let me just open my Eclipse. Uh, since it's based on Java, I like to work on Eclipse more when I'm working with Spring Boot applications specifically. Uh, it's kind of slow. Uh, yeah. So first, let me take you through the project structure. So here I have uh, the configurations and the controllers, user-defined exceptions, the models, the repository service. So everything works kind of in order. We have a controller which calls a service layer, and the service layer calls the repository layer, which then calls the uh, respective classes or the database layer, basically. Yeah. So let me first show you the models and explain the models that I implemented. So maybe I can start with the user.java. Yeah, yeah. So in order to reduce a lot of boiler code, uh, uh, I have used all these annotations, which have made it really easy for me to implement. Uh, yeah. So the this entity basically says that this user is an entity or a table in the database, and @table defines the name of the table, and @getter and setter generates the getter and setters, and no arg constructor and all arg constructor generate those constructor, and this @toString generate the toString functions. So here, and @id uh, makes this email a primary key, and this addresses is a different table which is joined to this users table with a very one-to-many relationship. So one user can have like many addresses, right? And similar implementation is there in every Pojo, plain old Java object. Uh, so these annotations made it really easy for me to implement this, right? And even so, let's go in order and let's talk about controller first, maybe. So I will talk about the user controller. Yeah. So in user controller, we first call the user services. We just use this @autovide annotation, which kind of inject all the properties of these user services inside this controller. And we also use this authentication manager and the availability provider beans inside our user controller. So whenever we want to create a user, we just call the appropriate method, in this case save user from the user services, right? And whenever we want to view all users, we call the appropriate method from the user services. And inside user services, uh, just a minute, yeah. Inside user services, we call the user repository, and the user repository is nothing but an interface which extends a CRUD repository, which is a kind of like a Spring implementation for the Spring framework. Right, this reduces a lot of boilerplate code or the code that we have to write in the database layer in order to interact with the database, right? And writing queries in this is like really simple. Let me show you an example. For example, in order.java, I have a order ID as a primary key, but I also have email, and I also want to check if the user is complete order is completed or not. And I want to get all the orders which are not completed. So in order repository, all I had to do is write this function, find by is completed, and I have to pass true or false. And here the find by is kind of the keyword, and whatever is the variable name is kind of becomes the query. So this is all the code that I had to write to implement this method, and JPA and Hibernate took over from here, and they kind of did all the work for me from this point onward. Um, so all the controllers are implemented in the same way, and I have almost around 17 endpoints or APIs which I'm using in order to create a user, update a user, and create order, update order, create dish, update dish, save new dish, kind of like that. I will also post push the Postman collection in the Git repo if uh, if it will it as it will make it a bit easier. Um, uh, the tricky part, there were a few of the tricky part that this project had. The first one was to save the image. So whenever I save a dish, I had to upload an image and save it to the database. I first thought that I would save it to like a file location on my disk, as it is done in mostly when you save a file. But I thought it would be much better if I could save it in a database. So first here what I did is that I get this multi-part file, and then I compress the image, and this compress the image is kind of the function which I wrote. After looking around a lot, I finally understood what is happening here. So I'm using this zip.deflator and inflator, which is kind of a library provided by Java. So this compresses the image and convert it into a byte array, kind of like a binary form, and then I save it inside uh, the database. And when I am getting this image, I just do the opposite. I decompress the image, and then I send it uh, in the as a response. So here I'm using same thing, but instead of a deflator, I am using a inflator. So this was a bit tricky to implement. This took some time for me. The other tricky part to implement was the JWT authentication part. So I have maybe I can show the controller first. Yeah, so I had to create this function post mapping called authenticate, which basically takes the user email and password and calls this function dot authenticate from the authentication manager, which is kind of implemented by the Spring framework. Uh, and I create the username password authentication token or the JWT token, right? So I had to implement all these classes, right? This username filter in order to filter all the URLs that are coming and whether the header has an authentication token or not, in order to validate and invalidate the session in the front end, uh, in order to secure the URL, like if a request doesn't have this JWT token, then it will be rejected. But there were some URLs that I had to like exclude from this. Uh, Maybe let me show you here. So in order to make the front end work properly, yeah. So here you can see that I override the configure function, right? And any URL that had like slash user slash image or slash dish and anything after that will not require a JWT token, and they will be valid all the time, whereas other URLs like order or image orders and I think just order will always require a JWT token or as the authorization in the header in order to communicate with the backend, right? This can be like further i- implemented, or if I want to have like a post dish or something to be secured, then I can like write the specific URL and then remove this. But for the time being, this worked for me. So this was also a bit tricky, and also before saving the password, uh, before saving the password, I am converting it to, uh, I'm encrypting it basically, uh, so that it is more secure. And I am using a byte 64 password encoder here. So whenever we create user, and if user does not already exist, then we first encode the password which we get and then we save it on the database. And when we get the user, right, yeah, we just get the encrypted password, but only inside authentication we kind of decode it and match it. So this was uh, all, I guess, about the backend. And let me show you the Docker file also, which I used in order to uh, create the image of this application. Yeah, so this is a Docker compose file, and these are basically Docker commands that you would write in order to create the image of your Spring Boot application. So here is like from OpenJDK 8. So this is kind of pulling an environment of OpenJDK 8, and then we add our jar from the target folder, and then we expose this port out and we define the entry point. So this 4 lines were required. So after uh, creating this Docker compose file, when I do like docker build and I define the image name, then Docker will basically do everything else for me. And there were some commands that I had to run. Oh, there was in order to get pull the image of MySQL database from Docker Hub, and in order to form a link between my Spring Boot application the and the MySQL database container. So I will put these commands also in the README file. These are basically simply 2 or 3 commands which were pretty straightforward. And maybe I can show this also. So this is the Docker desktop, and it shows all the logs and everything that has been happening in my backend. So this is the image that I created, and this is the Docker desktop, which allows you to basically manage your images and your containers. So currently I have 2 images running in 2 different containers, which is MySQL 5.6 and backend, which I created, right? And yeah, I can view the logs, and I can open a CLI, and I can directly query my database if I want to. So this is pretty good, and it saves a lot of time also, and it can be directly integrated with CI/CD pipelines on GitLab or on Azure platforms. So it is really nice to have, and I'm also thinking of working on this application more a little bit and deploying it, so that it can actually be used in the live world. But yeah, I think that was it. Thank you for listening to me, and I hope you liked this video. All right, have a good day.